So in the last class, we have discussed the mobility management. In that we have studied the S1 mobility and X2 interface. So can anyone tell which are the three phases of S1 interface and X2 interface? Three phases. Anybody?
The preparation, execution, and completion.
Okay, good. So and also we have discussed the RAN procedures for the mobility. So today we'll go with the paging. So here paging is a connection control function of the RRC protocol. So here the paging message is used to inform the user equipments in the RRC idle state or RRC connected state about a system information change. So here in the paging, so the user equipment in the RRC idle state monitors a paging channel to detect the incoming calls. So this system information can be transmitted a number of times with the same content within a modification period. So upon receiving a change in notification which is contained in the paging message, so here the user equipment will knows that the current system information is valid until the next modification period boundary. So here in the paging, so the EUTRN will initiate the paging procedure by transmitting the paging message at the user equipment's paging occasion. So here one paging frame, that is one paging frame, that is PF, is one radio frame in which the EUTRN, that is EUTRN, can be page the user equipment. So here if one paging frame may be contain one or more multiple subframes in which a paging message can be transmitted, and each subframe is called as paging occasion, so which is configured by the EUTRN. So here the paging information, so the paging information is carried on the physical downlink shared channel for the physical channel. So in a certain paging occasion, so here the user equipment is configured to decode the physical downlink control channel with the CRC scrambled by the paging radio network temporary identifier, that is a PRNTI, and then it is decoded the corresponding physical downlink shared channel for the information. So here to reduce the power consumption, so the user equipment may be discontinuous reception, that is DRX, in the idle model. So it will need only to monitor one page occasion per the DRX cycle. So here after receiving the paging message, so the user equipment can switch off to its receiver to preserve the battery power. So it will switch off, user can be switch off so to its receiver to preserve the battery power. So here the DRX cycle is configured by the EUTRN. So this is about the paging. So next we have an intercell yeah. Any doubts? So next we have an intercell interference coordination. So here in the intercell interference coordination, so each in the cellular networks, each of the user equipment will suffers the intercell interference, that is ICI, due to the frequency reuse in the other cells. So here the conventional cellular network by design are interference limited. So here if they were not, so it would be possible to increase the spectrum efficiency by lowering the frequency reuse or by increasing the average loading per cell. So here to meet the spectrum efficiency target, so here the LTE will be deployed with the universal frequency reuse, that is the same spectrum frequency will be reused in the each cell. So to meet the spectrum efficiency target, so the LTE will deployed with the universal frequency reuse, that is the same spectrum will be reused in the each cell. So here this will cause the high level of the intercell interference, so especially for the user equipments at the cell edge. So here meanwhile, so the LTE will also has a mandate to increase the cell edge throughput. So therefore the ICI, that is the intercell interference control techniques must be applied. So here we can discuss in this section we will discuss the ICI, that is intercell interference mitigation techniques for both the downlink and the uplink transmission. So here the basic approaches to mitigate the ICI in the downlink are, that is ICI randomization, ICI cancellation, and ICI coordination or avoidance. So similarly, the basic approaches to mitigate the ICI in the uplink are, that is ICI randomization, ICI cancellation, uplink power control, and ICI coordination or avoidance. So here coming to the downlink, so here in the downlink, so as I told here we have three approaches to mitigate the ICI. So coming to the ICI randomization, so here this is achieved by scrambling the code word after the channel coding with the pseudo random sequences. So here the ICI randomization, it is achieved by scrambling the code word after the channel coding with the pseudo random sequence. So here with the cell specific scrambling, so the ICI from the neighboring cells is randomized, and then the interference suppression is achieved. Intersymbol interferences, that is interference suppression is achieved. So here without scrambling, so the channel decoder might be equally matched to interfacing the signals as the desired signal on the same radio resources. So here the ICI randomization has been applied in the systems such as UMTS. It is a universal mobile telecommunication systems. So moving on to the ICI cancellation. So here if the user equipment is able to decode the interfering signal, it can be regenerate and then extract them for the desired signal, which can be achieved from the multiple user or multi-user detector at the user equipment. User detector at the user equipment. So here, however, to decode the interference signal, so here the equipment needs to know its transmission format, which is not available decode the PDCCH, that is physical downlink control channel from the neighboring cells. Intercell interference cancellation can also be performed in the spatial. So here the linear spatial linearization, statistical knowledge of the interference channel is a practical option for the intercell interference cancellation, but the application in the downlink as it's limited by the capability and the number of antennas at the user equipments. So here moving on to the ICI coordination or avoidance. So here this is achieved by applying the restrictions to the downlink resource management in a coordinated way between the neighboring cells. So it can be time frequency transmit power which is used at the E node B. So it also requires the additional the user measurements and the reporting. So coordination can be either static or semi-static. Here in this subsection, so we can focus on the more advanced technique and requires the additional signaling. So here the ICI coordination or avoidance can be static or semi-static. So here with the different inter E node B communication requirements at the another different performance. So yeah, the static ICI coordination or avoidance is mainly done cell planning process and does not require frequent configuration. So here the static coordination requires no little intra E node B signaling, but there is a performance limitation as the dynamic characteristics such as the cell loading or the user distributions are not taken into the consideration. So moving on to the semi-static ICI coordination. So your semi-static coordination typically requires the reconfiguration on a time scale of the order of the seconds or longer, and the inter E node B communication over the X2 interface is needed. So here the information exchanged between the neighboring E node Bs, E node base stations can be transmission power or the traffic load on the different resource blocks. So here by considering such information at the neighboring E node Bs, so here the intercell interference operation is more efficient. So here this figure will indicate the possible downlink power layers of the three neighboring cells. That is the edge users in the each cell would be allocated to the high power levels. So here we can see that the ICI coordination or avoidance is mainly scheduler implementation issue at the E node Bs. So here to assist such coordination, so the LTE. So here the LTE system defines the E node B power restriction signaling in the downlink. So which is a bitmap termed as the relative narrowband transmit power, that is RNTP indicator that can be exchanged between the E node B over the X2 interface. So here the each bit of the RNTP indicator corresponds to the only physical resource block, that is the PRB block, and it is used to indicate the maximum anticipated power on the critical resource. So here based on the relative narrowband transmit power indicators from the neighboring cells. So each E node be neighboring cells. Next we have an coordinated multi-point transmission. So here in the LTE advance to further improve the cell surge improvement, cell edge performance. So here the advanced techniques with the more sophisticated one like ICA. So what is the downlink COMP, that is coordinated transmission, implies the dynamic coordinated separated transmission points. So here it can be deployed in the form of coordinated scheduling or beamforming or the multi-cell joint transmission, which is essentially the same as the networked MIMO. Same as the networked MIMO. So here the COMP with the joint transmission theoretically can eliminate all the ICI and the transfer the cell network from an interference limited system to a noise limited system. So here there are many practical issues which are associated with the coordinated multi-point transmission. So it is a type of dynamic intercell interference coordination. So by deploying it, we have the great impacts on the radio interference specifications, such as the feedback and measurement mechanisms from the user equipment, and E node B, that is inter E node B signaling and downlink control reference signal design. So this is about the coordinated multi-point transmission. So next we will move on to the uplink. So here the basic approaches for the uplink mitigation are as follows. So that is the ICI randomization, ICI cancellation, uplink power control, and ICI, that is intercell interference coordination and avoidance. So here moving on to the ICI randomization. So here it is similar to the downlink ICI randomization. So here ICI randomization in the uplink, which is achieved by scrambling the encoded symbols which are prior to the modulation. So here instead of the cell specific scrambling as used in the downlink, so here user equipment specific scrambling is used in the uplink, as the intercell interference comes from the multiple user equipments in the neighboring cells. Is also similar to the is an intercell interference comes from the multi equipments in the cells. The ICI cell can ICI, it is downlink. So the higher computational capability and usually more antenna means. So next we have an uplink power control. So here in the uplink power control, it is an effective way to suppress the ICI in the uplink. So here the fraction power control, that is FPC, is also used in the LTE. So here the power control is an efficient way to suppress the ICI in the uplink. So the fractional power control FPC is used in the LTE. So next we have an ICI coordination or avoidance. So here it is also similar to the downlink. So FFR technique is used in the uplink.
Mana? Mana?
Fractional frequency reuse. FFR is the fractional frequency reuse.
Hello, Mr. Manohar.
Sir,
ಎಲ್ಲಿದ್ದೀರಾ ಸರ್?
good morning, sir. Sir.
ಎಲ್ರಿ ಇದ್ದೀರಾ?
Hello, sir.
ಯಾವ ಮಾಡ್ಯೂಲ್ ಮಾಡ್ತಾ ಇದ್ದೀರಿ?
ಸರ್. ಸರ್ 5th ಮಾಡ್ಯೂಲ್ ಸರ್.
6th ಮಾಡ್ಯೂಲ್?
5th ಮಾಡ್ಯೂಲ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಸರ್.